Okay, in this presentation, we're just going to go through a bunch of acid and base problems. Okay, first of all, I want you to figure out what is the proton concentration, the hydroxide concentration, and the pH of a 2.6 times 10 to the minus 5 molar solution of hydrobromic acid. Hydrobromic acid has the formula HBr. Okay, first of all, you'll write the equation for hydrobromic acid. Undergoing dissociation gives a proton plus a bromide ion. That since the concentration of this solution is 2.6 times 10 to the minus 5, we're just going to write that proton concentration is equal to 2.6 times 10 to the minus 5. Of course, the bromide is also equal to that, but the one that we're interested in is the proton concentration. I then also say proton concentration times hydroxide is equal to 1 times 10 to the minus 14. I rearrange that and I get that hydroxide is equal to 1 times 10 to the minus 14 over proton concentration. That is equal to, when I plug this number in down here, I get 3.85 times 10 to the minus 10. Now I need to figure out what my pH is. What number do I take to get my pH? If I take this number, that's my pOH that I would get if I took the negative log of this number. I want my pH, so I have to take my proton concentration. So I take negative log of 2.6 times 10 to the minus 5, and that gives me 4.59 is the pH of that solution. What is a proton concentration, which is the hydronium ion concentration, and hydroxide concentration of a 1 molar solution of sodium hydroxide? If I look at this, what does sodium hydroxide make in water? It just makes sodium ions and chloride ions. You're not adding protons and you're not adding hydroxide. So the proton concentration, the hydroxide concentration, and the pH is going to be the same as pure water. What is the proton concentration going to be? 1 times 10 to the minus 7. What's the hydroxide concentration going to be? 1 times 10 to the minus 7. And what's your pH? It's also 7. All the same concentrations in the pH of pure water. So what would be the proton concentration, the hydroxide concentration, and the pH of a 3.5 times 10 to the minus 4 molar solution of methanol? Well, if I look at this compound here, I see that it's a methyl with an OH. It is not a metal hydroxide. This doesn't dissociate in water. This is made of all nonmetals. How does this dissolve in water? This dissolves in water by hydrogen bonding, not by dissociation. So what's going to happen is you are only adding something that hydrogen bonds to water. It's not going to change proton concentration. You're not adding protons. It's not going to change hydroxide concentration. You're not adding hydroxide. So the proton concentration and hydroxide concentration, as well as the pH, is the same as pure water. So you can write down that hydronium ion and hydroxide concentration are equal to 1 times 10 to the minus 7, and the pH is 7. What happens to pH, proton concentration, and hydroxide concentration when you add magnesium hydroxide to a sodium carbonate solution? Okay, if we look at what we're doing, we don't have to worry about what kind of solution. We're just trying to find out what's the change that happens when you add magnesium hydroxide. Magnesium hydroxide is a metal hydroxide, so it's a base. What happens when you add a base to water? Well, hydroxide concentration is going to increase and your proton concentration is going to decrease. So your pH is going to do what? It is going to go up. So magnesium, because magnesium hydroxide is a base, the hydroxide concentration increases. the proton concentration decreases and pH increases. What happens to pH, proton concentration, and hydroxide when you drink Coke? And what happens to that in your mouth when you drink Coke? Remember that Coke contains both carbonic acid and phosphoric acid. It's very acidic. Dentists don't try to discourage you from drinking Coke, and they should, because it eats your tooth enamel up. But what happens to pH, proton concentration, and hydroxide concentration when you drink Coke? Well, because I'm adding acid to my mouth, what will happen? My proton concentration must go up. If my proton concentration goes up, hydroxide concentration goes down and pH goes down. Determine the proton concentration, the hydroxide concentration, and pH of a 2 × 10⁻³ molar solution of potassium hydroxide. Well, the first thing you need to do is write the formula for potassium that it dissociates into potassium and hydroxide ions. So that means that the concentrations of potassium and hydroxide are known. 0.2 molar KOH gives potassium concentration equals 0.02, and 0.002 of hydroxide. This is the ion that we need to know our concentration of. So now we use that proton concentration times hydroxide concentration is 1 × 10⁻14, and then arrange it so that proton concentration is 1 × 10⁻14 over hydroxide. You do the math and figure out that your proton concentration is 5 × 10⁻12. Now, what is my pH? My pH is my negative proton concentration. If I take the negative log of this number, that gives me pOH. If I take the negative log of this number, that gives me pH. So I take the negative log of this number, and it gives me 11.3. Do you see that negative log means P? So if I take the negative log of this, it's pOH. Negative log of this gives me pH. That's why we first look for proton concentration, then use that number to get our pH. There's something called an acid-base neutralization reaction. An acid will react with a base. Here you see hydrochloric acid and sodium hydroxide. What happens? You basically have the front of the base combined with the back of the acid to make a salt, and then the front of the acid combined with the back of the base to make water. A salt we define as that product of an acid-base neutralization reaction. A salt is always made from a metal hydroxide, well, not always, but a lot of times made from the front of a base with the back of an acid to give you a metal with a non-metal. And that's why we also define a salt as a metal with a non-metal.